Welcome to this session. My name is Bhunesh. I work for SentinelOne. I'm a cloud security specialist. I've been in this company for 3 years. I've been in the cloud security industry for over a decade. Um, and yeah, so we have a lot to sort of cover. I'll sort of go, straight, let's dive into it. In terms of the topic of discussion today is sort of understanding the evolution of threats in the cloud, how they have progressed over time, where we are with them today, and sort of understand the lessons learned so we can build a modern strategy for it. I'm very aware that we only have 30 minutes. This is going to be a lot of stuff to cover, so I'll skim through some of it. But myself and my colleague are here, and we are exhibiting at the show. So if any of these topics are of interest to you, please come and talk to us. As I mentioned, SentinelOne is a cybersecurity company. We are very fortunate to be at the forefront of the cloud security movement. So we have, picked up on a lot of observation on how the industry is changing and evolving over time. The first thing we have noticed that is changing in the cloud attack surface is that a very drastic increase in cloud-based attacks, specifically in public cloud targeting data. We have seen that because we all know that cloud has been very sort of aggressively adopted ever since COVID times. Most companies are now moving a lot of their workloads and their applications into the cloud. There are a lot of different metrics and research papers on that. Gartner predicts that 70% of modern enterprises today put some kind of their data into public cloud. Now, with the element of AI in that, and everybody trying to make the most of AI these days, this is only going to get bigger, and we're going to see more and more breaches in the cloud. It's not just the volume that is going up. We have also seen the sophistication of these attacks increasing very rapidly. One way to kind of look at or measure the sophistication of these attacks is to look at what the industry experts are doing to sort of remediate or find solutions for it. And one of the industry experts is called Mitra. They are like a knowledge base, and they have TTPs of all of these attacks. And they have increased the TTPs for infrastructure as service. So previously they had 50 checks for infrastructure as service. Now they have 61, and they're adding more and more. But it's not just the volume of attacks. It's not just the sophistication of these attacks. It's also how these attacks are performed. Now they are fully automated. They use things like Worm GPT, a lot of open source LLM models. There's a hacker group called Logbit, which have actually released ransomware as a service. If you are interested in sort of running ransomware, attacking someone, you can actually do it without actually fully understanding the technicalities behind it. It's making it even simpler for the non-sort of sophisticated attackers to attack with more intensity, more severely. And this has been a big challenge because most of these people who do these things, like ransomware as a service or automated attacks, they have monetary sort of incentives behind it, so they are willing to put more time and resources behind it. And for that reason, what happens is they eventually might be successful. While they only have to be successful once, you have to be successful every time protecting yourself against these things. Now, this is not all doom and gloom. It's not all bad because, as I mentioned, there are always ways we can tackle these challenges. And obviously, there are experts who have solutions, and we're going to discuss some of them. But let's sort of, turn the clock back and look at the history of these cloud attacks. I've compartmentalized these into 3 categories. The first one is sort of knock on the door kind of attacks. These are the attacks which were, in my opinion, more opportunist in nature. What I mean by that is these were things like malware, OS level, sort of exploiting OS and app vulnerabilities, OS style attacks, brute force logins, DDoS attacks. They used to exist even on premise, but they were opportunists in the cloud. What I mean by that is attackers a lot of the time didn't even know that the workloads they were attacking were running in the cloud or public cloud. The reason I'm calling it knock on the door is because they happen because your services were somehow connected to the internet. So if you're using internet, there will be at some point knock on the door sort of thing. That's the analogy behind it. The other kind of attacks were sort of in the supply chain, DevOps, pipeline kind of attacks. Um, these happen because of the nature of software development. I guess we cannot expect development processes to be, up to speed with security. The advancement in development have been so quick, security has not been able to play catch up. And things like, open source packages which were malicious, intentionally or unintentionally, that happens. Developers sometimes use code from repos which they don't even know are maintained or who's the owner of these repos. That happens. But also there's credential abuse, leaked compromises, very minor things within the supply chain which can cause a lot of drastic changes and essentially cause breaches in the cloud. This used to happen. And lastly, cloud misconfiguration. Now, this is probably the most popular one. Every time people think of cloud breaches, they think of cloud misconfigurations. This is probably what gets the most publicity. Things like, publicly encrypted or exposed objects, S3 buckets with, access to external IP, or unrestricted or privileged access, default credentials. These are like misconfigurations, essentially mistakes, things that could change, mistakes that could have, can be made when you're setting up an environment. So this was, the history of attacks, right? But these attacks have been evolving ever since. What we have seen is they have becoming more, like I said, more sophisticated, more automated, and the intensity has gone up. So if I look at the knock on the door kind of threat vectors in the cloud, we see things like sort of fileless attacks, right? Now, fileless attacks are the type of cyber attack that do not rely on traditional file-based malware. They use environmental components to hide themselves. And we have seen that these fileless attacks have been, up in the last 2 years. There's a company called Aqua Security. They do a lot of research on cloud security, and they observed a 14% increase in fileless attacks, specifically on Linux environments in the cloud. And now we already know that Linux was attacked previously, and this is not a new thing, but there are new kind of attacks happening in the Linux environment, predominantly attacking things like Linux-based workloads, VM servers, Kubernetes, containers, anything which is based on Linux becomes sort of a target. One of the things that SentinelOne does, we have a research team. They actually look into these things quite heavily, and they have come up with a lot of different vipers which are attacking Linux. Some of them are, and I'm going to name them, you might not have heard of them before, but Swift Slicer, which is written in Go. There's Acid Core Viper, which is targeting, again, Linux. There's Icefire Linux ransomware. Again, all of these are attacking workloads running in cloud environments. The other change within these attack vectors in the cloud is the use of things like cryptojacking for microservices or container-based workloads. This was really sort of high during the COVID times. And this is not just about resource drain. When you think of cryptojacking, is somebody obviously have access to your environment and they're draining your resources and they're running kind of crypto miners and stuff. This is about how exposed these workloads are, even when they're running in production. And these numbers, when you see numbers like 90% uptick in cryptojacking in last 2 years, these are not really good numbers. So we've seen new kind of attacks. Things like OS and application vulnerabilities, now they existed, but the evolution is that now the discovery of vulnerabilities and exploitation of those vulnerabilities can be automated. And you can use a lot of different kind of AI-based technologies. Now, you can see here malware polymorphism, right? This has existed, but now when you add the element of AI, where the malware can evolve while within the attack, it becomes very hard for even any best EDR product to detect. So even if you're running the best technologies, it can become impossible to detect these things, even early in the cycle or when you're running in production. The DevOps pipeline kind of attacks have also evolved, and there are a few examples of them here. So we have seen a uptick in targeted supply chain attacks. Again, there are so many different numbers on that. Gartner believes that 45% of enterprises this year will be exposed to some kind of supply chain attack. We have seen use of non-standard languages and code repositories, hiding in compilation, so a way for them to go around the traditional SEST and DEST kind of detection within CI/CD pipeline technologies. And we've also seen sort of things like code repositories being used to harvest credentials and malicious code. A very good example of sort of account takeover is I'm not sure if you guys heard of it. It's a popular Python repository called CTX, which was actually hijacked by a university student in Turkey because the owner of the repo was not maintaining it, and this kid basically got hold of it, and he reverse coded it in a way that any developer who uses this repo was sending the AWS credentials back to them. And he got a lot of hits, like thousands of hits, before it was shut down. So we're seeing things like that. We've also seen threat actors specifically going after developers. There's a group in Korea called Lazarus. What they do is they do social hacking. They reach out to developers, asking them for their CVs, running interview applications, which is obviously have malware in it. When they run that in their systems, they get access to their credentials, and so they try to get into their company's sort of network. So what we are seeing is that, yes, DevOps-style attacks existed, but previously they were a lot more related to sort of minor things like bad code or misconfigured resources, etc. But now they're becoming a bit more intentional. Even cloud misconfigurations are changing, right? Historically, whenever this topic comes up, people give example of S3 bucket, which is open to an external IP. This is a very popular misconfiguration. But what's happening now is that once these hackers get access, they are not just looking at these sort of static misconfigurations. They are looking at sort of getting in and changing things on the go. So once you get access to say AWS environment, you're going in, targeting IAM roles and policies, changing those policies on the go, so you can get hold of the environment, and then obviously once you get hold of the environment, you can ask for ransom and do whatever. So misconfigurations are becoming a lot more tricky to detect, only because the technology has not been able to catch up with it. So any misconfiguration tools that you use today will be able to tell you that a resource is exposed to a public IP, but they won't be able to tell you if there was a live attack happening and which is causing that resource misconfiguration, right? So it's really hard to kind of find the actual problem with this amount of alerts that are generated from these technologies, which are, again, very much geared towards detection, but not able to sort of build context on what's actually happening. So that takes us to what exactly where are we now with that sort of stuff? Like obviously we know traditional attacks like knock on the door, we know attacks in the supply chain, we know misconfigurations happen. What we actually realize is that these attacks all work in combination, where these attackers are not just doing things individually, going after these areas individually, but they're combining these things, these tactics, techniques for cloud environments. And I'll give you a few examples of that. Again, I'm not going to go in a lot of detail because this is a very hefty topic, but I'll try and give you the gist of what these attacks were doing, and what the impact of these attacks were on the company and how were they able to get in. But before we do that, so this is what Mitra's TTPs look like for cloud. I'm gonna read them to you. So they have initial access, TTPs for initial access, execution, persistence, privilege escalations, defense evasion, credential access, discovery, lateral movement, collection, data exfiltration, and impact. All of these are interchangeable. When you think of these TTPs, you're thinking about not just cloud infrastructure, but you're thinking about how they can impact identity or any cloud service. Because again, these attackers are not just running in silo environment. They try to move laterally and exploit whatever they can. And these attacks, again, are a lot more sophisticated. So if you look at these examples, I'm gonna bring up these examples now. Like I said, I'm not gonna go in a lot of detail, but to give you an idea of how these work, right? So the first attack example is of a global retail company in the US. In this example, the attacker exploited a vulnerable PHP web application to gain initial access. Once they got the initial access, what they did was they found IAM roles and permissions through sort of instance metadata, and they used cron jobs to download malicious implant called Silver. They harvested the credentials into the metadata, and then they were running commands like curl to download the malicious data. This is where they were caught because the organization looked at some curl command downloading some malicious content, and then they obviously tried to piece together, did an investigation, and sort of stopped the attack. This is not overly serious. The reason to bring this up is to kind of show that it's not just about exploiting a web application, but it's also exploiting misconfiguration in this example. Another example is of a Australian company. Attackers sort of exploited the vulnerability in WSO2, a tool for authentication and API management, which allowed them to get remote code executions. They used sort of common tools like wget and curl to download the malicious software from a Chinese-based code repository. And what they did was they changed the time steps on the web server and avoid detection, right? They used sort of time stomping techniques. What they did was then they used AWS CLI to a tool to explore the network and find sensitive files, and they tried to kind of move those files. And they were trying to move those files from cloud onto on-premise, and this is where the customer sort of picked it up because they were making sort of movement from cloud onto on-prem environments. The impact of this incident was sort of 3 days of downtime for the customer and a significant drop in the share price, but again, not so detrimental, right? But again, multiple sort of vectors were used in this as well: automation, misconfiguration, identity-based IAM changing policies. The last one is an example of an American technology company, quite big. I'm not going to name this company, but this is a public one. But the attackers obtained user credentials through phishing campaign, and they accessed the Azure AD and AWS IAM. And what they did was then they used AWS System Manager inventory to list and discover network details, and then they used that to create a MFA, and that used that to then spin up EC2 instances with privileged access. Essentially what they were able to do is they were able to do all of this while bypassing the security controls like guard duty and CloudTrail. And then they were able to successfully deploy the ransomware. The ransomware stole a lot of their data, encrypted their data, and essentially forced them to pay the ransom which was paid. And sort of Black Hat have a copy of the customer data and the entire extortion thing. You can look it up. In this case, obviously, they had to pay the ransom. This is not, didn't work out well for the customer. So the few things that we observe from this is that each attack leveraged misconfiguration in the cloud to gain initial access, and then they used, escalate, and then they use sort of privileged access to change certain things within the environment, like IAM roles or credentials. And they obviously use automated tooling for vulnerability harvesting and credential harvesting. But a lot of this is done with a lot of confidence, and they did it in a lot of ease, a lot of confidence and ease, really. It wasn't even that hard because these are not very complicated attacks. So what exactly is the problem, with the existing tooling in the cloud, which is not able to detect these things because we have, so many different acronyms in security, which can look at sort of misconfiguration, identity, like when you think of cloud security, there are things like CSPM, CIEM, which is identity and access management. There's DSPM, which is data security posture management. There's EDR for cloud. There's so many different things, right? But none of them are able to build that correlation to find the context on and able to prevent things happening and being able to detect them early. And the reason for that is they all work in silos. When you think of static code analysis tools in your supply chain, in a development cycle and DevOps, those teams and those tools generally don't talk to your SOC teams. the things that you're running in your SOC usually don't have access to the platform teams. This disjointed approach is, in my opinion, is causing a lot of this sort of complication. And the ones that are able to detect or are able to correlate this data, they become too noisy, and it's impossible for customers to see what is real and what is just an alert, which does not really need much attention. And with that noise, you move your attention to something else and you forget about it, and then you open yourself to potential disasters. So what is needed? I mean, there's obviously a unified way of doing things would be nicer, right? You can look at things like a CNAP a proposition. I'll cover that in the next slide. But the idea is to consolidate your different functions of security into one within one area. It doesn't have to be cloud security, SOC, network security separately, but it should have a unified way of looking at data, correlating that data, going through it, so you can do better forensics, you can do better investigation, you can build better prevention policies. Bringing teams together. I mean, this is more of a cultural thing where developer or DevOps teams start working with security and SecOps teams. And I guess being able to adapt, and this is probably the most important bit, is to be able to adapt sort of the attacker's mindset. Instead of thinking about, hey, we're going to prevent, we have all the right things, we're going to prevent it, but being able to see what the attacker is able to see is the key here. So running penetration testing, running audits on a regular basis, these sort of things might help in preventing some of these things. And lastly, being able to respond to these attacks at machine speed. As I mentioned, a lot of these technologies that we have today are very much geared, especially in the cloud, they're very much geared towards detection only. They find out what's wrong, and then you are left with something to fix, which might not be an easy fix. Nothing is actually preventing things from happening. So very, very few technologies which are preventive technologies in the cloud. So, finding ways so you can merge detection and prevention together, and obviously correlating different teams might be an easier way here. But one sort of blueprint you can look at is this. This is by Gartner again. They have detailed many different ways or many different checks or things that you have to do when you think of security in the cloud, all the way from sort of developer-focused checks to things running in the cloud, which are more about cloud services, to when things are actually running in production, so you can monitor these applications on the go. They are calling it CNAP. This is probably something which is going to evolve over time. Right now, there's not much about data in it, or there's not much emphasis on identity. I'm sure this is going to evolve and add all of these elements. This is right now looking at just the cloud as a standalone environment. I feel like it needs to add endpoints and other environments and hybrid environments into the mix, so you can again get this holistic view. But this is by far the closest we have gotten to having a more comprehensive approach to cloud security. And if you write CNAP tooling, you will find a whole bunch of different companies doing it now. Everybody has their own way of fixing that problem. But there's stuff there which can help you get started to kind of have a standard framework that you can implement quite easily. And lastly, I mentioned that AI is becoming a thing. Obviously, everybody is going to be talking about AI at some point. We also have at SentinelOne a very good AI-based technology, which sort of consolidates different data points and allows our LLMs to kind of understand and then make meaning of it. But besides that, I think because our adversaries are now using technologies which are very much AI-based, it is only sensible to use tools which are obviously going to be AI-based. Humans will not be able to sort of go through the mammoth amount of data that these tools are generating. So the idea of AI in security, is very important. So whenever you do look into technologies or tools and practices, make sure that whatever you pick has some sort of AI capabilities built into it, because this is what's going to be a huge differentiator. So with that, Thank you. I hope it was useful for you guys. Like I said, this is very much skimming through very detailed and technical data. If any of that is of interest, I'll be around here at one of the SentinelOne booths. So if you have any questions, please come and talk to us.